So right off the bat, we can remove ideal as being one of the possibilities, because looking at the experimental values collected, sensor 2 and 4 should be theoretically the same, or agree with each other within their uncertainties. But we can see after doing inequality tests that sensor 4 has a noticeably smaller amount of pressure. And this tells us, because sensor 2 is upstream from sensor 4, this tells us that there is friction in the system because pressure is being lost. In addition, looking at Bernoulli's equation, calculating a theoretical value for the pressure in sensor 3 specifically, it does not agree with the experimental value of sensor 3 either. So that's just another piece of evidence that the liquid is not frictionless. So in order to test the theory that this is a Newtonian liquid, we need to first calculate the theoretical pressure of a Newtonian liquid and kind of compare that to the experimental value. So first up, I calculated the pressure lost using the experimental values. So to do that, I subtracted sensors 2 and 4 and then divided by 2, and that gives the estimated lost pressure at sensor 4. So then I took the theoretical value calculated previously, because again, that's the value you would get if it was a frictionless liquid, and then I subtracted the pressure lost, so kind of accounting for if it were a Newtonian liquid and if there was constant friction present. And so I ended up getting 103,560 pascals minus 60 pascals. And the 60 pascals was the estimated pressure loss at sensor 3. And that gave me a pressure of 103,500 pascals. So the final value I got was 103,500 plus or minus 100 pascals. So comparing that to the experimental value of 103,410 plus or minus 50 pascals, when you do the equality test to determine whether or not these values agree with each other, you get a difference of 90 pascals, subtracting those two values, and then 150 pascals when you take the sum of the uncertainties. And since the difference between the two values is smaller than the sum of the uncertainties, that means that the values agree with each other. And essentially, because the Newtonian value agrees with our experimental value, that suggests that the friction is constant and it is predictable, because we're able to mathematically determine the pressure. So yeah, the liquid is probably Newtonian.